Hello all. In this lecture we discuss about the basic problem related to the signal flow graph and analysis the transfer function of the different types of circuit, different types of signal flow graph analysis. Okay, so first of all consider one signal flow graph. It is okay. Now mention here that okay, now our first problem, the two forward paths are shown and one loop is considered. Say for example, this is a forward path, gain G1, G3, and there is another forward path, gain G2, and this is a feedback path, gain minus H1, and these output C and these input R. Okay, these and signal flow graph. Now first of all, here first forward path P1 is the gain equal to G1 into G3 and delta 1 equal to 1. Why delta 1? Because there is a no non-touching loops, every loop touching the forward path. Now P2 is equals to G2 into G3 and here delta 2 equal to 1. Okay, now consider for L1, here only one non-touching loop whose gain equal to minus G3 into H1. Now if we consider C by R, then what is the formula? P1 delta 1 plus P2 delta 2 by delta. So here P1 equals to, yes right, G1 into G3 plus G2 into G3, and delta equals to 1 minus 1 non-touching loop, so minus of minus G3 into H1, so G1 into G3 plus G2 into G3 divided by 1 plus G3 into H1. This is our total CS by RS response for this particular signal flow graph analysis. Okay, so next we consider the another example. For the another example, say consider here another signal flow graph. This R, these are the nodes and these output and these input, and from here to here there is one feedback is present, minus H1. These two nodes, the transmittance is G1 and these transmittance are gain equal to G2. Here one unity feedback is applied, minus 1, the transmittance is equal to 1, and there is a one forward path is exist, that is called G3. Okay, so now first start one, what is a P1, G1 into G2 into 1, therefore delta 1 equal to 1. What is the value of P2? P2 equals to G1 into G3, G1 into G3, and also delta 2 equal to 1. Okay, and now L1 first, this is one non-touching loop, so formula is minus G1 G2 into H1. Okay, right, and what is L2? L2 is basically, just consider this is the feedback. Okay, so minus G3, because G3 into minus 1 minus G3. So there are no non-touching loops. So now what is the value of delta? Delta is equals to 1 minus of L1 plus L2, that is the total value equals to 1 plus L1 plus L2, this is L1, right? Okay, right, and yeah, right, there is another loop are present in this problem, because there is L3 also present, because this is an L3. Okay, right, yeah. So the value of L3 equal to, what is the value of L3? that is equals to minus G2. Okay, so from starting from here, here and here. Okay, so that's why G2 is considered here. Okay, and for G3 there is a consideration of there is a G1 G2 forward path, one G1 G2 for this loop, and it's just seen here that just look here from this point, this is the feedback path from here and then via this path. Okay, so that's why here G3 is mentioned here. Okay, so this is include here L3, so the value is 1 plus G2 plus G3 plus G1 G2 into each one. Okay, so now what is a C by R? C by R again P1 delta 1 plus P2 delta 2 by delta. So putting this value and you're getting the result C by R ratio. So now this is another example of the signal flow graph. Okay, now we again come back another example. Say for consider here the signal R. This is one node, there is one node, there is another node, there is C, and now from there is a transmittance parameter G1, there transmittance 1, this G2, this is 1. Okay, so now from here to here, this is the parameter G3, this is G1 minus H1, this is minus H2. Okay, so now first forward path P1 G1 into G2, and there is a no non-touching loop, so this is 1. What is the value of P2? This is the P2, that is G1 into G3, again delta 2 equal to 1. Now for L1 this is minus G2 into H2, and for L2 for this loop minus G1 G2 into H1. For L3 there is another loop, the loop is, yeah right, that is G1 G2 G3 G1 G2 G1 then G2 for L3 G1 G2 G3 and H1 H2. Okay, right, there is a L3 loop is shown in this figure. Okay, this is G1, the path is from here, from G1 G3, then minus H2, then G1, then I come back to this. Okay, okay, right, so that's why here G3 is present. Okay, so therefore our delta equals to 1 minus L1 plus L2 plus L3. So putting this value here, and finally C by R equal to P1 delta 1 P2 delta 2 by delta. Okay, now we talk about another problem. Now consider for this signal flow graph analysis method. Now for this method, these are, this is G1 transmittance, this is G2 transmittance, transmittance, this is G4 transmittance, this is 1, and from here to here minus H4 is a 1 unity feedback is present, and from here to here G5 is another forward path, from here to here minus H2 is a feedback, this is output C, and from here to here there is another forward path known as G3. Okay, right? Now we analyze the circuit signal flow graph. Now first of all, in this problem we see that therefore this is the first non-touching loop, one loop, that is L1 equal to minus G4 into H1. Now what is the value of L2? L2 is a G2 G4, so G2, this G4. Okay, so now there is a G2 G4, starting from this G2 G4 1 and then come back to this path, so minus H2. So basically G2 G4 minus H2, minus of G2 G4 H2. Now what is L3? L3, look here, that G2 G5 G2 and then G5 and then minus H2. Okay, it is very easy to determine these values. So now what is the value of delta? This 1 minus L1 plus L2 plus L3. So putting this value here, we get the delta here. Now see that there is a 1 forward path, 2 forward path, 3 forward path. Okay, now see, right, for the first forward path the gain is G1, G2 and G4. This G1, G2 and then G4. Okay, into 1, and there is delta 1 equal to 1 also. Now for 2 there is a G1, G2, G5 into 1, and delta 2 always 1, G1, G2, G5, that means G1, G2 and then G5, that means from this path. Now we study about P3. For the part 3 there is only one gain and exists, that is G3. Okay, now delta 3. Now coming to the point, what is value of delta 3? Look here, students, when you follow this path G3, this loop is not touching in the via this loop. When we follow this path G3, then this loop is not touching, because this loop, that means G2 G4 1 into H2, this larger loop is touch here, that means from this node, at this node, but between these two nodes there is one loop is created and this loop is non-touching, no touching here. So that's why here value of delta 3, as we mentioned, 1 plus of that particular loop gain, that means 1 plus, what is the value? G4 H1. Okay, so that means, sorry, this is 1 minus, yeah, right, minus G4 into H1, that means this is 1 plus G4 into H1. So that's how delta 3 is not equal to 1 here. So now we see that here C by R equals to P1 delta 1, P2 delta 2 plus P3 delta 3 divided by total delta. So now putting this value P1 delta 1, P2 delta 2, P3 delta 3 and delta, we get the whole transfer function of the particular, for this particular signal flow graph analysis. Now coming to the another problem. Now in this problem, show that there is an input signal R followed by a transmittance G1. This is the transmission G1, here transmittance G2, and here minus H1. There is a transmittance 1, here transmittance G3, there is a minus H2, and from here to here this is G4 and this is C, and from here to here there is a G5. The forward path is exist. This is G1, 1, G2, again 1, G3 and G4. Okay, G4, sorry, this is from here. Okay, not here. I again show here that this loop gain is touching from here. This is a forward path. Okay, so now after this the gain is G4 and then C. Our output is taken from here. Okay, that okay, right. So now calculate this. So now what we'll do first? We'll do first what is a non-touching loops. L1 loop gain. This is our minus G2 into H1. Then this L2 equals to minus G3 into H2, right? Yeah. Now delta, what is the value of delta? 1 minus L1 plus L2. Now putting this value, we get the value 1 plus G2 into H1 plus G3 into H2, right? Now what is the forward path? First B, what is the P1? G1, G2, G3, G4. This is a straight calculation. G1 into G2 into G3 into G4 into 1, because from this node to this node gain equal to 1 and delta 1 equal to 1, because there is a no non-touching loops for the forward path. Every loop are touching. Okay, every loops are touching. Now for the P2 path, the path is G1, G5 and then G4. Okay, now G1, G5 and G4. Okay, right? And one thing should be remembered here, delta 2 for this forward path, this is one non-touching loop. So that means the formula is, what is our formula? 1 minus for that loop gain. So this is 1 plus G2 into H1. Okay, what is the loop gain of this? Because this non-touching loop gain equal to minus G2 into H1. Okay, so now C by R again, P1 delta 1, P2 delta 2 divided by total delta. Okay, now this is another problem. For this problem we show that how signal flow analysis is done by the signal flow graph analysis. So it is not a very complicated method. You just find the non-touching loops, 3 non-touching, 2 non-touching loops, and calculate the corresponding gain. Say for another example, the R, these are the nodes. Okay, this is again G1, there is again G2, there is again G3, there is again G4, there is G5, and the feedback is present here, minus H1, from minus H2, minus H3 and minus H4. Okay, this is our C. So now here one only forward path, P1 equals to G1, G2, G3, G4 and G5. Okay, no non-touching loops. Yeah, right. So what is L1 first? L1 first means this loop minus G1 into H1. Okay, L2 means minus G2 into H2. Okay, right. What is the L3? Minus G2 into H3, right? What is the L4? Minus G5 into H4, right? So these are the one non-touching loop. But here one problem arises. If we consider L11 means 2 non-touching loop. That means this loop and this loop are non-touching. So just product there again, minus G1 into H1 multiply into minus G2 into H3, because these two are individually non-touching. So this is L11. Okay, so for L12, these and these, and then these and these, that is minus G1 into H1 into minus G5 into H4. Okay, now there is no non-touching for this loop. Now for these and this and these and this. Okay, so now again L21 is equals to minus G2 into H2 into minus G4 into H3. Yes, this L22 equals to minus G2 into H2. Yes, right, minus G5 into H4. Yes, that means for this loop these and these are not touching, these and these are not touching, these and these and these and this. So there are basically 4 values. So what is the value of our delta here? Delta is 1 minus L1 plus L2 plus L3 plus L4 individually 4 non-touching, and plus, remember that L11 plus L12 plus L21, sorry, plus L22. So this is our delta here in this problem. So that's why I show this problem. In this problem there are some changes in a formula of delta. So that's why in the Masongen formula, the typical formula, it noted Masongen formula indicates that 1 minus 1 non-touching loop plus 2 non-touching loop minus 3 non-touching loop. If there are 3 non-touching for the complex signal flow graph, there are also 3 non-touching, and 4 non-touching, 5 non-touching, there are lots of feedback are present, but here only one feedback one forward path, and for the one forward path there is a no non-touching loop, so therefore the delta 1 equals to only 1. So now what is our Masongen formula? Masongen formula C by R, that is equal to P1 into delta 1, because there is no another path. And what is the formula? This is a L1 plus L2, this is a minus sign, sorry, this is a minus, L3 plus, this is a plus sign, L21, L22, L12 and L21 and L11, sorry. Okay, just putting this value, and we get the actual result of this signal flow graph, the transfer function for this signal flow graph. Okay, now this is another problem. In the another problem, it is your homework, that there is another forward path is present, that is for, say, for G6. Now for this forward path, there P2 is equal to only G6, but what is the delta 2? Yeah, right, for these there are 2 non-touching, these and these. Okay, so it should be in a mind that delta 2 there is a 1 minus L1 minus L2. Okay, minus L1 minus L2. Okay, right, because there are 2 non-touching, because when this forward path is going from here to here, this loop and this loop are non-touchings, so therefore individual gains are represented here. So this is very important for signal flow graph analysis. Otherwise the problem, there is a there is an error produced, the output by input response. Okay.